The sanctions were supposed to work. That was the assumption in Washington back in 2022. Restrict the lithography machines, cut access to advanced GPUs, pressure allies like the Netherlands and Japan to tighten exports, slow China's semiconductor industry long enough, and eventually the gap becomes permanent. Instead, a university lab quietly graduated its first class of advanced chip process engineers, 43 students. That's the number people keep missing, not because it's large, because it's small enough to matter. Modern semiconductor manufacturing doesn't collapse because you lack buildings, or subsidies, or patriotic speeches about technological independence. It collapses because a tiny number of highly specialized engineers fail to stabilize production yields at absurd levels of precision. A single contamination issue inside a fabrication plant can destroy millions of dollars worth of wafers in hours. One calibration error measured in nanometers can turn an advanced chip line into an expensive concrete box. And Beijing knows this. That's why this story isn't really about a university. It's about how China quietly shifted from chasing technology to cultivating the people capable of reproducing it under pressure. The lab itself was embedded inside a provincial university program tied to semiconductor manufacturing partnerships, local government funding pools, and state-backed fabrication projects connected to China's broader industrial strategy. On paper, it looked academic. In practice, it resembled a wartime technical pipeline. Not dramatic wartime propaganda, something colder, methodical. Students weren't simply studying semiconductor theory. They were reportedly rotating through process simulation environments, packaging systems, defect analysis workflows, and yield optimization exercises designed around actual manufacturing bottlenecks facing domestic Chinese fabs. Which tells you something important. This program wasn't built for prestige. It was built to solve production pain points. That distinction matters more than people realize, because there's a persistent Western assumption that China's semiconductor push is mostly imitation. Copy the architecture, acquire foreign talent, buy what equipment you can, reverse engineer the rest. Some of that absolutely happened. Countries industrialize however they can. The United States did it, Japan did it, South Korea did it. Taiwan certainly did not emerge as a semiconductor giant through pure free market accident. But something changed after the export controls. China stopped behaving like a country trying to catch up quickly and started behaving like a country preparing for technological siege. Different mindset entirely. And you can see the transition everywhere once you notice it. Municipal semiconductor funds, regional fabrication clusters, expanded materials research programs, talent subsidies, state-guided procurement chains, university partnerships directly aligned with industrial targets under initiatives linked to the Ministry of Industry and Information Technology. The strange part is how little public attention this receives compared to AI chatbots or flashy product launches. Probably because training process engineers is boring. No charismatic founder standing on stage, no cinematic rocket launch, just graduate students spending years learning how to reduce defect densities inside clean rooms most people will never see. Yet this is the layer that determines whether sanctions actually work long-term. There's also an uncomfortable irony here. The more pressure Washington applies, the more China's system starts resembling the industrial mobilization structures that historically produce technological self-sufficiency during periods of isolation. Not immediately, not perfectly, and definitely not without waste. China's chip sector still faces serious obstacles, especially around EUV lithography, where companies like ASML remain critical bottlenecks. But sanctions may have accidentally clarified Beijing's priorities. Very few governments sustain focus without external pressure. China received pressure in industrial quantities, and universities became part of the response. That's the piece most headlines still miss. The real competition here isn't just about machines. It's about whether an entire generation of engineers can be cultivated fast enough to replace dependence before economic friction turns into technological separation. Because if these 43 students are successful, they won't stay 43 for very long. Inside an advanced chip fab, nobody celebrates when a chip works. They celebrate when thousands work consistently. That sounds obvious until you realize how brutal semiconductor manufacturing actually is. A modern process node can involve more than 1,000 production steps across deposition, etching, ion implantation, cleaning, metrology, and packaging. The machine matters, the software matters, but the invisible layer underneath all of it is process stability. Engineers constantly adjusting variables so microscopic defects don't spiral into catastrophic yield losses. This is where China still trails the frontier. And this is exactly why these university programs exist. A lot of commentary around the chip war treats semiconductors like oil fields. Either you have the resource or you don't. Reality is uglier. Chip making is accumulated experience. Tiny manufacturing instincts built over decades. The reason companies like Taiwan Semiconductor Manufacturing Company became dominant wasn't magic. It was repetition. Millions of production cycles. Thousands of engineering corrections. Entire corporate cultures built around reducing failure rates by fractions of a percent. Fractions that translate into billions of dollars. One former semiconductor executive described advanced fabs as factories that fight physics for a living. Honestly, that may still be the best definition I've heard. And China's problem after 2022 became painfully simple. How do you continue fighting physics when the world's most advanced tools are increasingly restricted? The answer Beijing arrived at seems to be volume. Not just production volume, human volume. More engineers, more domestic suppliers, more research partnerships, more local governments throwing money into semiconductor parks even when half of them fail. Especially when half of them fail. Western analysts sometimes mock this approach because many Chinese chip projects collapsed under corruption, poor planning, or unrealistic targets. Fair criticism. Between 2020 and 2023, several state-backed semiconductor ventures reportedly burned through billions without delivering meaningful production capacity. But here's the uncomfortable part. Industrial revolutions are usually messy. Japan's rise had failures. South Korea's did too. Early American industrialization was full of bankrupt rail projects, terrible factories, and speculative bubbles that detonated entire fortunes. We remember the winners and retroactively edit out the chaos. China's semiconductor ecosystem currently contains both genuine progress and spectacular waste at the same time. Those realities are not contradictory. Take SMIC, for example. After the October 2022 export restrictions from the U.S. Commerce Department, many analysts assumed China's domestic foundries would stall badly at mature nodes. Then, Huawei released the Mate 60 Pro in 2023, with a domestically produced 7-nanometer class chip manufactured by Semiconductor Manufacturing International Corporation. That launch caused genuine shock inside Washington. Not because the chip matched Taiwan's frontier, it didn't, but because it proved China could still push forward under restrictions many assumed would freeze progress almost immediately. The funny part is that Huawei unveiled the phone during a visit to China by U.S. Commerce Secretary Gina Raimondo. Timing like that almost feels rude, or strategic, possibly both. Still, there's a mistake people make after seeing developments like this. They assume China is secretly winning the entire semiconductor race. I don't think that's true, at least not yet. China remains heavily dependent on foreign equipment in multiple layers of the supply chain. Advanced lithography is still a massive obstacle. High-end EDA software remains another vulnerability. Memory chips, advanced packaging, materials purity, precision optics. These are ecosystems, not single technologies, and ecosystems take time. Which brings us back to those students, because the hidden logic behind Beijing's strategy may not be to surpass the United States quickly. It may simply be to survive long enough that technological containment becomes economically impossible to maintain. That is a very different goal, and honestly, probably the smarter one. The strange thing about the semiconductor war is that neither side can fully afford to win it. That sounds ridiculous at first, until you start tracing where the money actually flows. The United States leads in chip design, advanced tooling, and critical software layers. Taiwan dominates frontier manufacturing through Taiwan Semiconductor Manufacturing Company. The Netherlands controls extreme ultraviolet lithography through ASML. South Korea remains essential in memory production. Japan supplies key chemicals and materials. And China? China buys almost all of it. In some years, semiconductors have cost China more than oil imports. Think about that for a second. The world's largest manufacturing economy became dependent on foreign microchips, the way industrial powers once depended on energy shipments. That dependency terrified Beijing long before most people outside China noticed it, which explains why the response has become so aggressive. But there's another side to this equation people rarely discuss openly. Global semiconductor companies became financially dependent on China too. Before restrictions tightened, major U.S. chip firms derived enormous portions of their revenue from Chinese customers. Companies don't just walk away from markets containing hundreds of billions in demand because politicians suddenly rediscover industrial policy after 30 years of outsourcing it. That tension sits underneath everything. Washington wants to slow China's technological ascent without detonating the profits of its own technology sector. China wants self-sufficiency without severing itself from the advanced ecosystem it still partially relies on. Both sides are trying to reduce dependence while remaining economically entangled enough to avoid collapse. That is not a stable arrangement. And this is where the university story becomes bigger than a university. Those 43 graduates are part of something closer to strategic insulation. China understands that if access to foreign technology becomes conditional, then domestic capability stops being an economic ambition and starts becoming national security infrastructure. The U.S. reached the same conclusion years ago, just from the opposite direction. Look at the CHIPS and Science Act passed in 2022. Over $50 billion aimed at rebuilding domestic semiconductor manufacturing and research capacity inside the United States. Suddenly, everyone remembered that letting critical supply chains drift overseas might carry consequences. Amazing how quickly free market absolutism disappears when advanced missiles, AI systems, and military communications depend on the same chips used in smartphones. There's also a deeper irony here. For decades, globalization trained countries to optimize for efficiency. Cheapest supplier wins, lowest manufacturing cost wins. Redundancy was considered wasteful. National resilience sounded old-fashioned. Then COVID disrupted supply chains, geopolitical tensions exploded, and governments realized their industrial systems were balanced on logistics networks stretched across oceans and political fault lines. Semiconductors exposed that fragility more brutally than almost anything else. A fire at a Japanese chip materials plant could disrupt automotive production across continents. One drought in Taiwan threatened fabrication water supplies. A military crisis around the Taiwan Strait suddenly became an economic nightmare scenario for the entire planet. All this because civilization quietly handed microscopic silicon wafers the responsibility for running nearly everything. Cars, hospitals, satellites, banking systems, data centers, power grids, even refrigerators now contain more processing power than NASA used during Apollo missions, which is either impressive or slightly embarrassing depending on your perspective. But here's the reversal most people still resist. The chip war may not ultimately produce separation. It may produce duplication. Parallel supply chains, parallel research ecosystems, parallel manufacturing blocks. Not a clean technological iron curtain, but a slower fragmentation where countries increasingly build backup systems because trust itself has become unstable. That process is already underway. And once universities begin training engineers specifically for industrial resilience rather than pure innovation, you're no longer looking at a temporary policy response. You're looking at a civilization-scale adjustment. Nobody outside China would have cared about those 43 graduates 10 years ago. That's the uncomfortable shift. A university semiconductor program used to be a local education story. Maybe a trade publication mentions it. Maybe a provincial official gives a speech nobody remembers. End of story. But the moment advanced chips became geopolitical leverage, engineering students became strategic assets. And once that happens, countries start thinking differently. You can already see the psychological transition underway in both Washington and Beijing. Less faith in global interdependence, more emphasis on redundancy, domestic capacity, trusted supply chains, technological sovereignty. The language sounds bureaucratic until you translate it into plain English. Nobody trusts the system to remain stable anymore. That changes investment decisions, education priorities, immigration policies, military planning, even the geography of cities. A semiconductor fab is not just a factory. It drags entire ecosystems behind it. Chemical suppliers, ultra-pure water systems, precision manufacturing firms, logistics infrastructure, research universities, energy grids. One advanced facility can reshape a regional economy for decades. Which is why governments are now throwing staggering amounts of money at semiconductor infrastructure, despite the risks. Because losing access feels worse. And honestly, this is where I think a lot of Western commentary still underestimates China. Not technologically, structurally. People keep analyzing China's chip ambitions like a normal business competition. Better products, faster growth, market share. But Beijing increasingly treats semiconductors the way states historically treated steel production, shipbuilding, or energy independence during periods of strategic tension, as survival infrastructure. That mindset produces different behavior, longer timelines, higher tolerance for inefficiency, greater willingness to absorb financial losses that private companies would never accept. Democracies can absolutely compete with that model. The United States still holds enormous advantages in research depth, elite universities, software ecosystems, and capital markets. But democracies also struggle with sustained focus. China doesn't have to dominate the global chip industry to alter the balance. It may only need to become sufficiently self-reliant that sanctions stop functioning as meaningful pressure tools. That's a much more achievable target. And if Beijing reaches it, the consequences extend far beyond semiconductors. Every country watching will absorb the same lesson. Strategic dependence is dangerous when geopolitics hardens, which means more governments will start building domestic industrial buffers even when it's economically inefficient. More duplication, more fragmentation, less trust. The world we spent 30 years constructing around hyper-efficient globalization may slowly give way to something heavier and more regionalized. Not because politicians gave speeches about it, but because supply chain shocks and technological restrictions convinced governments that efficiency without resilience is fragile. Those 43 students are tiny inside that story, and still incredibly important, because history sometimes turns quietly at first, not with explosions or declarations, but with small groups of engineers walking out of anonymous buildings, carrying knowledge their governments suddenly consider essential. One final thought, though. There's a tendency to frame the semiconductor race as if one side eventually wins and the other loses. I'm not convinced reality will be that clean. The more likely outcome is a world where technological systems become partially duplicated, partially separated, and permanently more expensive, which is ironic. For decades, globalization promised cheaper and more connected systems. The future now arriving looks slower, less efficient, and far more suspicious. All because humanity decided to build civilization on tiny pieces of silicon measured in nanometers, and then turned those nanometers into a geopolitical weapon. If you enjoyed this, stick around. There's a lot happening beneath the headlines right now, and most of it is far more consequential than people realize.